Right, good afternoon to you all. We almost completed relationship in databases. In relationship, there are three types available, right? So one-to-one relationship, one-to-many relationship, and also many-to-many relationship, right? So I clearly explain about one-to-one and one-to-many. I explain them with the help of some examples. You know, examples are always helpful in understanding the concept, right? So there is no need for memorizing everything. Right? Understand some examples, and then only these things will be in your mind forever, right? So let's take a quick revision on these two relationships, right? So we talked about one-to-one relationship. So what is it? What is one-to-one? You may have two tables, right? There are two tables. A data in the first table, right? A data in the first table has only one similar data in the second table, right? Every data must have only one similar data in the second table. And also, data in the second table, this one, must have only one similar data in the first table. In both directions, you must have one-to-one connection. But this idea or this description can be modified and given more meaning for different tables, right? So this one-to-one has special meanings in tables, right? So it depends actually on the table. I clearly explained this, right? So then we discussed about one-to-many. Okay, let's take it again, one-to-many. Right. So in one-to-many, in one direction, there should be one-to-one relationship. In the opposite direction, in the other direction, it must be one-to-many relationship, right? So one-to-one can be found in any direction. If it is one-to-one, the opposite should be one-to-many, right? So you have two tables again, right? So assume there is a table called X, you have another table called Y, right? So if it is one-to-many, so I take a data here, assume that data has two similar data in the second table, right? This data has two similar data, which means the same data entered twice in the second table. So here it is one-to-many. In this direction, it is one-to-many. If it is one-to-many, the opposite must be one-to-one. So here, if you take a data here, somewhere here, assume we have a data there, that data, not only that data, every data, right? Every data must have only one similar data there. Okay, so this is one-to-many, right? So come to many-to-many. Many-to-many relationship, right? So again, you must have two tables. So assume we have a table here. So I take this as table X, and also I have another table, right? So this is table Y. So if it is many-to-many, right? If these two tables have many-to-many, they must have a characteristic, right? Any idea, anyone? What about many-to-many characteristic? Any guesses? Artana?
They should not be primary keys.
Sorry?
They should not be primary keys.
Okay, I am unable to hear. Okay, doesn't matter. Look, I will explain. So if it is many-to-many, simply in both direction, it must be one-to-many. right, in both direction, right, it is one to many. From here to here, one to many. Even in the opposite, it must be one to many. So if it is one to one in both direction, it is one to one. If it is one to many in one direction, it is one to one. In opposite, it must be one to many. But here in many to many, there should be one to many relationship found in both directions. So if I take these two tables again, so here assume there is the data. I take a data there. That data must have more than one similar data in table 1. Again, I take a data in table X. That data must have more than one similar data. So if I have the data, that must be entered twice, right? That data, similar data must be found twice. The data in the first table must have two similar data in the second table. So it is one to many, right? So here one, right, here two times, which means many. Even in the opposite direction, there should be one to many. For example, assume there is a data, right? There is a data. So I take a data, I'm checking in the opposite direction. So if it is data, that must have more than one similar data in the first table. So if it is a data, that must have two similar data. So assume you have two. So here I have a data that has two similar data in the second table, which means many data. Similarly, a data here, right, in this direction, there is a data that has again two similar data. So in both direction, it must be one to many. Okay, let's discuss further because this seems to be little complex. So it would be better if I take the example again, right? So wait patiently. I will show an example and see you how to create many to many, right? Right. Look. So assume we have two tables. Let me take a table as student. This is student table. Okay. So we have some fields there like admission number, S name, which means student name, date of birth, and also I put subject ID there, SID, subject ID. I tell you the reason, right? Subject ID. So this is student table. And also I have another table for storing subjects data. So this is subject table, right? Subject table. So there we have, let's say subject ID, SID, and subject name, S name or SUB name, subject name, right? So let me fill some data in order to explain, because if a table has data, then only we can justify the type of relationship, right? So let me add some data. So here 1000. Let me give a name like Saman. There is a date of birth, right? Then SID, subject ID. So there is a subject. Okay, later we will, fill. So another student, 1001, right? Female, 5/10/1990. Then another one, 1002, Pereira, 10/11/1991. Let me add one more, 1005, right? Nuwan, 11/11/1990. These are the details, or these are the data of students, 4 students. I have 4 students. And I have to enter their subjects. So assume there is a subject called 80, subject number, and it is ICT. Then there is another one like 81 or something, which is maths. Right, 65, another number, science. Okay, let's add one more, 40, right, 40, it's English. Okay, so this table has subject data, this table has student data, but in order to make the relationship, right, because we have two tables, both have related data because students always follow subjects, so there is a connection between these two. So that's the reason why I use the relationship, right? So assume the primary key here is admission number, right? In student table, the admission number is the primary key because it is, or it has a unique value. So since it has unique value, it has the eligibility to become as primary key. In subject table, every subject has a special number that never be repeated. 80 is given for ICT, so that never be repeated. So since subject ID is the unique field, I take it as primary key. So here it's a primary key, here it's a primary key. So now I have added this primary key in student table as foreign key, right? Because in student table, primary key is admission number. So this is foreign key. Okay, so let me add this one. 80, 81, 80, 40. Okay, right. So listen to me very careful because it's too important, right? You have to understand the concept clearly, right? So I have two tables, student table and subject table, and also there are data, right? So now assume these two tables have one-to-many relationship, right? I take the relationship as one-to-many, right? I don't want you to identify the relationship because there may be some confusions. So that may be the reason why I suggested the relationship type, right? So for me, it's one-to-many, right? Okay. So let's understand the meaning of one-to-many first, right? So to understand this one-to-many, it would be better to take my diagram, so, right? So hope you remember the diagram which I have displayed on the other day. Even though they are not important or they are not recommended for your syllabus, I took it because if you use such diagram, this is too simple to understand the concept, right? So here I have a student table. So let me put as a student table. This is student table. And I put a small rectangle and write the table name inside. And also I have subject table. So on the other side, subject table. Okay, subject table. So there should be a relationship because there is a common field available. So SID is available in both tables. So there is a relationship. So put a small diamond symbol there. Right. So since this table has students data, this table has subject data, there is a connection between students and subject. So what is the relationship? Students study subject or follow subject. I write a verb there, follow. Right? Student follow subject or student study subject. Anything is okay, right? Okay. So now it is one-to-many. I already suggested, right, that these two tables have one-to-many. Okay, let's understand the meaning. So can anyone tell me what is one-to-many here? What does it mean? Take your time and answer me. What is the meaning of one-to-many here? Anyone? You have enough skill, you have the experience, I already explained. Anyone? What is the meaning of one-to-many here?
One student can follow many subjects.
Yes.
Many subjects can be followed by one student.
One subject can follow many subjects. One student can follow many subjects. Is it correct? Okay. Okay, listen to me, listen, I will explain. Look, there may be confusions. Even though my tables are not appropriate, I took it because from these tables, I will move to many. That may be the reason why I took it, right? Without asking you to identify the relationship, I put it because I know there is a confusion is there, right? So in order to avoid that one, I put it. Okay, it is one to many. Have a look at this. You have two tables, right? You have two tables. In this table, SID there, student table, and also subject table has SID. This is the primary key, this is the foreign key. So now the relationship is there. It is because of these two SIDs, right? Okay. Now time to find out the relationship, but I already told you that it is one to many. So how? Look here, look at this table. This table has subjects, ICT 80, Maths 81, Science 65, English 40. Okay. I already told you that it is primary key. So if it is primary key, it never be repeated. You know, 80 cannot be repeated. Okay. And also I told you that admission number is the primary key there. In the first table, admission number is the primary key. So 1000 never be repeated because I already declared that as primary key. Okay, right. Now keep an eye on SID. Right? Look here, SID. Look at these two data, right? Look at these two data. See, right? 80 entered twice. 80 entered here and also 80 entered here. So now you can have some idea, right? Okay, let's see. Have to check one by one. So we can check from student to subject, right? So student to subject. This is student, this is subject. I will check in this direction, right? From here to here. I want to check from student to subject to get or to identify the relationship, right? So here, how to check that? Check the data there. Take a data. I take 80. Okay, I take a data in student table. So 80. How many times 80 added here or entered here? Only one day, only one time. Because we already discussed that SID never be repeated. So now 80 is there in student number, sorry, student table. That data has only one similar data in the second table. Okay, right. It seems to be one to one. Let's move. Check the second data. 81, right? I take the second data, which is 81. So that data has only one similar data there. Again, take another data, third data, 80, right? I take another data, 80, a data. How many times 80 there? Only one. If you take 40, I take the 40 there, right? A data, how many times it is there? Only one. So now what is the conclusion? When you move from student to subject, you find one-to-one connection, right? Every data in student table has only one similar data in subject table. So in this direction, it is one-to-one. Have you understood? I explained similar incidents, similar questions on the other day. So it is one-to-one. But you cannot confirm or you cannot conclude the whole relationship. You cannot say that it is one-to-one. In one direction, you found one-to-one. Right? So take a look at the opposite one. Right? So now you have to move on the opposite direction from here to here. From subject to, right? From subject to student. Okay? From subject to student. So how to identify, take a subject here. Now you have to start from here and move towards student table. So here 80, I have a data there, right? A data. How many times 80 there? 2 times. A data in subject table, which is 80. That 80 has 2 similar data in student table. That is more than enough to finalize your relationship. No need to check the rest of the data because now you got the maximum, you got the highest. So a data in subject table here, right? A data in subject table has many data in student table. 2 data means many. So what is it? It is one to many. So now have a look at this. In one direction, it is one to one. In the opposite direction, it is one to many. So what is the conclusion? So it is one to many relationship, because we all know that in one to many, in one direction it is one to one, in opposite it must be one to many. So it is one to many. So now come to the meaning of this one to many. So where should I put one? See here, one, look here, one to one, one to many. So where should I put one? Okay, tell me why did we add 80 twice there? What is the reason for adding 80 there twice? Anyone answer me? Why did we add 80 twice there? Don't take time, answer me. Why?
Because
What is the reason?
ICT can be followed by many students.
Which means a subject is followed by many students. 80, yes, ICT, 80, one subject. That subject is followed by 2 students. See, Saman also follows, Pereira also follows. So a subject is followed by 2 students. So what is the idea? But okay, in this direction, okay, a subject, right? A subject is followed by 2 students. But in the opposite direction, okay, let me explain, or let me put the value first. A subject, right? A subject is followed by many students. So in one side, put 1. In the other side, put M. Look here, I put 1 in the subject side and put M in the student side. So now you can understand, see. Okay, let's check the relationship in this direction. So in subject, I have 1. So which means one subject, a subject is followed by many students. That is exactly same as this. One subject is followed by many students. But what about the opposite? Even though it is many, don't take that as many. It is 1, right? In opposite, you have to start from 1. So here, if you take the opposite direction, here student, here if even though you have many, take it as 1. I already explained the reason of having that as 1 in the last class, right? So it is 1. So one student, right? One student can follow one subject, right? One student can follow one subject. But in the opposite direction, a subject is followed by many students. Okay, so according to these 2 tables, a student cannot follow more than one subject, right? A student cannot follow more than one subject. For me, a student can follow only one subject. That's the reason why I have already told you that it is one to many. You may argue that a student can have more than one subject. That is possible. But in my case, I don't allow that. It is because to show one to many, right? So if a student follows more than one subject, then there is a problem, right? You cannot say that it is one to many. So here it is one to many because in one side it is one to many, in opposite it is one to one. Okay, so in these 2 tables, a subject, right? A subject is followed by 2 students or many students. However, a student can follow only one subject. See, this summon, right? Take the summon. This summon can follow only 80, right? This summon can follow only 80 because admission number is the primary key. I already told you that the admission number is the primary key. So suppose if summon follows another subject, assume the summon follows maths also, right? Summon takes 2 subjects. The first subject is ICT, the second subject is maths. The entry for ICT has already been written, right? So now summon follows maths also. So you cannot put 80 comma, right? You cannot put 80 comma 81. That is not the way. In a cell, you have to write only one data, right? You cannot put 80 comma 81. That is not. So if summon follows maths, you don't have any choices. So you have to rewrite the sum and record. How? 1000, right? Listen to me. 1000, summons date of birth 10/10/1990. This time summon follows maths. What's the number? 81. Have you understood? I have written this record because summon follows two subjects. Summon follows ICT, that is the first record. ICT has 80 as ID, so that is 80. In addition to ICT, summon follows maths. So I cannot write the maths number there in the same cell. So rather than writing the maths number, I have added a new row. So there we have summon admission number, the name of the person, and the date of birth, and now SID. So now let me check the relationship. Listen to me very carefully, right? Let me check the relationship, right? Okay. So again, erase this. Right. Now start from student table, right? We can start from student table here and go towards subject table, right? Starting from student table and move towards subject table. So how to check? We already studied, right? Take a data there, right? Take a data in SID, first table, okay, 80. How many times 80 there in the second table? Only one, right? Only one. Okay, wait 1 second. Before I take such thing, okay, I must explain one more thing. We already checked, right? We already checked that a subject, right? A subject is followed by two students. Saman C, ICT is followed by Saman and Pereira. So that is one to many. Now, a particular student follows two subjects according to my last record, right? So as soon as I have added last record, you have another meaning. A particular student follows two subjects. So here Saman follows 80, which means ICT, and also 81 maths. So now in this diagram, right, listen to me, in this diagram, I can show you one subject is followed by many students, okay, right? At the same time, one student, right? If I take one here, one student can follow, right? Summon. One student can follow two subjects. What is it? One too many. Have you understood? In this direction, we already found that answer. One too many. Since I have a new record there, I have another meaningful sentence. One student can follow many subjects. Take a look at the summon. So summon can follow both ICT and maths. So now I can say one student can follow many subjects. So since one to many is found in both directions, you have one to many in this direction, and also you have one to many in the opposite direction. So since one to many is found in both directions, what is it? The final conclusion is many to many. In between two tables, you have many to many, because I already told you in many to many, we have one to many connection in both directions. But what about this record? Is it correct? Can I have a record like this in the table? I have added this record at last because to show one many to many relationship. Because if it is many to many, a student should follow many subjects. A student should follow many subjects. So I thought about this issue and added that summon again, because the same person should follow another subject. So I did not have any options. I put the summon admission number, name, date of birth, and SID. Now it seems to be many to many because in both directions we have one to many. So here in this, you can find this data, right? One subject is followed by two students. ICT is followed by 2 students. That is this one, 1 minute. You have 2 times summon. Why? A student follows 2 subjects. So in both directions, you have 1 to many. My question is my last record correctly entered? Is it correct?
No, sir.
Why? What is the reason?
Because admission number is the primary key
Yes.
of students table.
Yes, yes. That admission number is the primary key. Right? I already told you, right? Admission number is the primary key. So since admission number is the primary key, you cannot add that. You cannot repeat the 1000. If you repeat the 1000, definitely it is no longer primary key. But it must be the primary key in student, because look here, the relationship is made with the help of primary key and foreign key concept. So in this table, subject table, SID is the primary key. In student table, admission number is the primary key. Therefore, SID is the foreign key. You know the foreign key concept, right? So since SID is the primary key, if you think that the SID is the foreign key here, definitely admission number is the primary key. We all know that admission number cannot repeat because it's a primary key here. So you cannot write this record. This is wrong. So if you are unable to write a record like this, then how to show the many to many? Because you know that name should be repeated, right? If name is not repeated, then how to show that 1 to many, which means a student follows many subjects. If you want to show this idea, right? If you want to show a student to follow many subjects, definitely the name to be repeated. If name is repeated, you know, admission number 2 repeated. So there is a confusion, right? Okay, let's see how to solve this. So I cannot add this. Right, listen. So I come to the point now. So we have 2 tables. We want to make them as many to many relationship, which means in both directions there should be 1 to many, right? In both directions there should be 1 to many. So it looks like this, right? One student can follow many subjects. One subject is followed by many students. Both must be reflected. So we tried to add the summon again, but we couldn't because it violates the primary key concept. So we can't. So if it is many to many, we need to find or we need to follow another idea, another technique. Before I take that technique, okay, I'm asking one question. Right, look here. It is important. First table is student table. Second table is subject table. In the second table, we have SID and subject name. It means subject ID and subject name. In the first table, admission number, S name, date of birth. Okay. Now keep an eye on the last field in the student table, right? Focus on the last field in the student table, right? So everyone knows, listen to me, everyone knows that this is not the right place to have this field, right? This field, which means SID, should be added or should be available in subject table, because SID means subject ID. So it is a characteristic of subject. So have you understood? I'm trying to say that this SID must have or must be available in subject table. Okay, that is there, right? You can see SID in subject table. There is no doubt. But rather than, okay, in addition to this SID, right? In addition to this SID, we have added this SID in student table, right? So what's the reason for adding this student SID here? Because, you know, in student table, you have to save student data. In subject table, you have to keep subject table. That's okay. But what's the reason for adding SID in the student table, I already explained, right? It is for relationship, right? This SID is added in student table. It is because of the relationship. Because here it is the primary key. So a common field must be there in both table. So to have a relationship, I have added this SID in the second table. So now let me remove that. Listen to me. I want to remove that. Have you understood? Our tables looked like this earlier, right? Before making a relationship or before creating the relationship, tables looked like this. You have subject table and also you have student table. But there is a connection between student and subject because students always follow subjects. So now we need a common field to create the relationship. That's why I tried SID here, right? In order to create the relationship, I took SID, or I have added SID in student table, but after adding SID in student table, I realized that it is wrong, right? It is wrong because it is not working for me. So now we have to take another idea. It's very simple, listen to me. If it is many to many, you need to have another table, right? You need to have another table because we cannot add the SID there to have the relationship, because if you add the SID there, the admission number is repeated. So we cannot solve that. So rather than adding this field, this primary key as foreign key there, you need to have another idea. You need to have a third table. In addition to these two tables, you need a third table, which is called junction table. Junction table. The reason for giving this name is it is the table to connect these two tables. I tell you, right? I will explain. This table will join these two tables. That's the reason why it is called junction table. Okay, let's see. It's very simple. So let's create this junction table. So in order to create the junction table, you have to identify the primary keys of your existing table, right? You have to check your existing tables and their primary keys. So what is the primary key in student table? Admission number. So take the admission number. That is one field. Bring all the primary keys from your tables. So this is the primary key. So I took it. So we have two tables, right? So we have another table. There SID is the primary key. Add that field to SID. So this is the junction table. That junction table has primary keys of other two tables, right? So you have admission number there. That admission number is added. You have subject ID there. It is added. Now you can fill the data and justify many to many. Okay, wait for some time. I will fill the data and explain about many to many concept, right? Listen to me. So I put the number 1000 there. It is 80. 1001. It is 81. 1000 again. It is 81. 1002. 65. 1005. 40 or something. Right. Now take a look at this table. I have randomly filled the data. Right. Now you have student table, you have subject table. In addition to these two, you have a new table which has admission number and subject ID. So I can say, I can give a name there like student subject. Student subject. Because that table has no new data. Look at the data which the table has. This table doesn't have new things. This table has data which are taken from student table as well as subject table. That is the reason why I have added those names, student subject table. Right? So you have three tables. Okay, now let's find out, or let's identify the relationship, right? So if you have two tables, you can simply check both common fields. Assume you have two tables, you ask to find the type of relationship. Now your task is simple. You have to check the common field and start from one side. You have to take a data and see how many times the similar data is found in the second table. After finding that, you have to go in the opposite direction. Take a data in the second table and see how many times it is entered in the first table. This is how you check the, or you identify the relationship when you have two tables. But here you have three tables. So now my question is same, the type of relationship. We have to identify the type of relationship. It's very simple, right? It's very simple. Look here. This is student table, this is subject table. You know, both tables have relationship because, you know, student follows subject. We know there is a connection between student and subject because students are the ones who follow. Okay, right. Now, if you take student and subject, take a look at student and subject, student table and subject table into consideration. Now, if you take student and subject, you cannot find any common field. But we used to find the type of relationship in this manner. We compared the two tables and checked the type of relationship. But now, take a look at these two tables, student table and subject table. The student table has admission number, S name, date of birth. Here, SID and subject name. Do they have any common field? No. So you may think that these two tables are not connected. You may think that these two tables do not have any relationship. If you think so, your thought is wrong. Because remember, from this table, admission number is taken. From this table, SID is taken. So in these two tables, we have taken two fields and composed and created a new table. So for me or for you, admission number is nothing, it's student table. You know, admission number represents student table. So imagine or assume this ADN or admission number is a student table. Don't worry about the other fields. Check the common field, because even in the previous we checked only common field. We didn't worry about the others. So now this table has admission number, that is the representation of student table. There is SID, that is the representation of what? Subject table. So it is too easy to identify the relationship. You can avoid these two tables. We can ignore these two tables because from this table ADNO is taken. From this table SID is taken. Both are in a single table. Try checking the single table. Try checking the junction table and find the relationship. You don't need to worry about student and subject. Have you understood? Because in two tables, there is a common field or there is a primary key. That primary key is taken. So you don't need to worry about such table. Keep an eye on the junction table. If you analyze the junction table, you can easily find the relationship. See, it's too easy. Now, look here, 1000 entered twice. Listen to me. 1000, admission number 1000 entered twice. Before I explain that one, let me remind one more thing. This is student table, this is subject table. Looks like this. Right? So if you have student and if you have subject, what is the connection? Students follow subject or student study subject, right? Okay. Now, 2 times 1000 entered there. What does this mean? You have 1000 twice. Tell me, what does it mean?
The student follow two subjects.
Sorry, repeat that.
Follow two subjects.
One student follow two subjects.
Yes. One student follow two subjects. Right? Look at that highlighted data 1000. So I have highlighted 1000, which means one student. Who is it? 1000. Look here, Saman. So Saman follows 80, which means ICT, and 81, which means maths. Now come here, one student, right? Look here, look at this. One student can study many subjects. So this is okay. In one direction, this is perfect. Have you understood? Earlier, we couldn't get that. When we had two tables, we couldn't get this conclusion. But it's too simple. Now, 1000 can be repeated because here admission number is not the primary key. Okay, tell me, what's the primary key in student subject table? What's the primary key here in student table? Admission number. Here in subject table, SID. What's the primary key in student subject table?
There is
Admission
no
number.
primary key.
Is it admission number?
There is no primary keys.
Yes, there is no primary key. So what does this table have?
Composite.
Yes.
Composite primary keys.
Composite
Yes.
primary key.
Yes, composite primary key. So here composite primary key ADNO plus SID. So now you can understand that admission number can be repeated. Right? 1000 can be repeated many times, not twice, thrice, 4 times possible. So it is one student can follow many subjects. Got it? Okay. Now keep an eye on the SID, right? Second field, SID, right? Keep an eye on the second field, SID. So there also you have data which are repeated. Okay, look here, 81, 81. 81, 81. Why 81 twice?
One subject can be followed by many students.
Yes, one subject, right? One subject is followed by many students. So 81, right? What is it? 81. Check the subject table. It is maths, right? Maths is followed or maths is studied by 1001, which means Saman. The same subject is followed, 1001, which means Vimal, and the same subject is followed by 1000, which means Saman. So maths, right? It is a single subject. That single subject is followed by 2 students, right? So here I take a subject there, right? One subject. That one subject is followed by many students. So even in the opposite direction, you have one-to-many relationship. In both direction, right? In both direction, you have one-to-many. So what's the conclusion? It is many-to-many, because in many-to-many, right? In many-to-many, in both direction, it must be one-to-many. So here also it is one-to-many. Even in the opposite also we have one-to-many. So this is many-to-many relationship. When you write many-to-many, you can put M one side. On the other side, it must be N, right? You may start N there, right? And also M. This is also applicable, right? You can put the N in one side and M is another side. So without having this junction table, right? Without having this junction table, you know, you cannot create the relationship, right? So because earlier I took this type of time or too much of time to explain this idea, because if I explain the junction table directly, you cannot understand. That's the reason why I have added that SID in student table earlier, and we found that it is wrong, because if you add the SID there, you cannot have a student twice, right? So since you have the problem, so we removed that SID and created another subject which is called junction table, right? In junction table, both primary keys must be added, right? Primary key of student table is admission number, that is added, and also the primary key of subject table is SID, that is also added. Now it is a composite primary key. So now look here, in exam, right? In exam, listen to me. In exam, they may ask you whether the student table, listen to me, right? Whether the student table, or do the student table and subject table have any relationship? So they may ask you to write the relationship between student table and subject table. write the relationship, right? Relationship between student table and subject table. What is your answer? What is the relationship between student and subject table? Student table, subject table. What's the relationship? Type of relationship?
Many to many.
Do they have, is there any relationship?
If junction table is present,
Wait 1 second. I'm repeating my question. Write down the type of relationship between the table student and subject. Student, subject. What is your answer?
No relationship. No relationship.
No relationship. Others? This. Is it correct? No relationship? Okay, listen. So here in student table, right, in student table, you have admission number, S name and DOB. In subject table, you have SID, subject name. So is there any common field in these two tables? Is there any common field? No, right? Is there any common field?
No.
No, right? There is no common field. But we already studied that if two tables need to be connected together, there should be a common field. So since the question is the type of relationship between student and subject, you may have some confusion because you checked both tables and found no common field. So now you may think that there is no relationship, right? You may argue that there is no relationship, but your answer, your idea is wrong because not admission number is taken from student table and added in student subject table. Subject ID is taken from subject table and added in student subject table. So asking the question like the relationship between student and subject means this one, right? So check this table, right? Because it seems that they don't, okay, wait a minute. So here it seems that there is no relationship because no common field. But now I can say that this admission number in student table can be connected with this admission number. So now we argue or we can confirm that student table and student subject table can be joined because this admission number is found there. So with the help of admission numbers, we can join the table. Similarly, this SID can be connected with that SID because it's a primary key here, that is foreign key. Because it's a composite primary key, SID alone is a foreign key. So this primary key and that foreign key connected. This primary key and this foreign key connected. Now the equation is too simple. Look, student table is connected to student subject table. Subject table also connected to student subject table. So we can say that student table is connected to subject table. Have you understood? A is connected to B. B is connected to C. So I can say A is connected to C. Have you understood? So for that question, you must have the answer. Check the junction table and find out the relationship. How to check? Check the data. If two data repeated, right? Here many. If two data repeated, they are many. So it is simply many to many. Have you understood? So check 1000 entered twice, it is many. 81 entered twice, it is many. So it is many to many relationship. So you cannot check these two tables to find. In one to one and in one to many, you can check the two tables. But when it comes to many, check the junction table. For someone who studies in grade 10, these much elaborated things actually not important, not necessary. But I took some time to explain because if you are able to understand, it's better, right? But I don't think that people who prepare the papers or set the papers never expect such skills from you. But I hope that you can understand because if you are able to understand one to many and one to one, it is not hard to understand, right? So it is called junction because this is the table essential for joining these two tables. These two tables cannot be related directly. So that's the reason why we have this table. So this table is connected with this one and this one is connected this one. So this is the junction. You know, junction is a place where many roads are joined. So similarly, here there is a road, here there is a road, both are joined. So that is junction. Okay, right. So have a look at this table. Before we wind up, I will show one more example. I don't want to take much time, but have a look at this. Right. So keep an eye on these three tables. Listen to me. Assume these tables are maintained by a canteen, right? A canteen keeps food details in food item table. And there should be suppliers for canteen. So suppliers details are there in supplier table. And also, you know, canteen purchase things from suppliers, right? Purchasing details are there. Okay. Food items and also supplier purchase table. Now, listen to me. So what is the relationship between food item table and supplier table? Take your time. What is the relationship between food item table and supplier table?
Many to many.
Many to many. Others? Any others? I repeat my question. The relationship between food item table and supplier table.
Many to many, sir.
Sorry?
Many to many.
Many to many.
Many to many.
Okay, how to identify? I take a minute or two to explain briefly, right? So I'm taking your time, but maybe in the next class I explain in detail. Look here. So you have items. This is one table, right? Items. And also you have suppliers. I put this kind of a diagram to explain easily, right? So this is item supplier. So what is the connection between item and supplier? Maybe purchase or maybe supply or something. Right? So items can be supplied by supplier. So even you can argue in the opposite direction, supplier can supply items. I am running a canteen, I have suppliers supply items. That's the idea shown here. Right? In this supplier table, suppliers details are there. In the food item table, food items are there. This is the purchasing table. So now I'm asking the relationship between food item table and supplier table, these two tables. Look here, this is the primary key. Item ID is the primary key there. In supplier table, SUPP ID is the primary key. You can understand, right? SUPP ID is the primary key. So here in food item table, item ID is the primary key. In supplier table, SUPP ID is the primary key. There is no common field, right? In between food item table and supplier table, there is no common field. So now you should realize that there may be a junction table like this. So what happens now? Item ID from food item table added here. So in food item table, that is primary key, but here it is the foreign key. In supply ID, SUPP ID is the primary key. That same SUPP ID is entered here, is the primary key. Now, if I ask you to find out the relationship between these two tables, between food item table and supplier table, you cannot compare these two tables. Check this purchasing table. So look here, 1003 entered twice. I briefly explain. 1003 entered twice. Why? One item, right? 1003, which means, look here, rolls. One item is supplied by many suppliers. S1001 is summon. Look at this table, is summon. S1003 is NIAS. So this role, one item is supplied many supplier, right? One item is supplied by many many supplier. Now look here, 1003, sorry, S003 twice, enter twice. You have S003 twice. Why? One supplier, which means NIAS, right? One supplier supplies two products. What are the two products? 1003 rolls and 1004. What is 1004? Patties. So one supplier supplies many food items. So in both directions, you have one to many. So which means many to many. Since the time is up, I ran fast, but definitely I will take this example again to clarify. But for me, many to many is not important for exams. It may be important, but not for exam. But if you are able to understand, it's fine, right? So again, I have to repeat the same thing. You have to spend some time at home to revise these things. If you do so, it will be very simple, right? So at this point, we can conclude and meet in the next class, right? Thank you.